vast expanse of the universe, the planet Neptune stands as a puzzle, a mystery waiting to be unraveled. It was discovered by an astronomer who noticed perturbations in the orbit of Uranus, a planet that lies closer to the Sun. These perturbations indicated the presence of another celestial body, which they named Neptune after the Roman god of the sea. Neptune is the 8th planet in our solar system and the farthest from Earth, located approximately 2.9 billion miles or 4.7 billion kilometers away. It is a frigid, icy giant with a blue-green hue, and its icy landforms and multiple moons make it a sight to behold. NASA's Voyager 2 is the first spacecraft that was able to reach the further parts of our solar system where Neptune and Uranus reside. It sent back pictures of Neptune's moons, violent storms, and rings. Yes, rings. Saturn is not the only planet with rings. Neptune also has 6 sets of extraordinary rings. Clearly, the universe loved it so much that it had to put that many rings on it. Despite the planet's beauty, scientists have been trying to unravel its secrets for years, and it seems that at long last they have discovered something interesting. Our solar system is made up of huge planets, some of which are filled with gas, and Neptune is among these gas planets. However, unlike some of these gas giants, Neptune is also made up of molten rocky materials, melting ice, and a rich supply of water. The water is mostly ice, and scientists have discovered that these icy layers have oceans under them. Interestingly, these oceans contain a high level of magnesium and might not even be made up of water at all. So, what makes up an ocean if not water? Neptune has a weird magnetic field. Apart from Neptune and Uranus, no other planet in our solar system has such magnetic fields. It is unlike Earth's magnetic field, which is similar to a bar magnet and works like a dynamo, which converts kinetic energy into electrical current. Neptune's magnetic poles are tilted 47 degrees, and scientists believe that the tilt is because of its fast rotation. The magnetic poles are vastly different from the north and south poles. If we take a magnetic compass to Neptune, it will point south rather than north. That's how confusing Neptune's magnetic field is. Nevertheless, Neptune's magnetic field is more than 20 times as powerful as Earth's. The ice giant has 14 moons and takes about 165 years to complete one revolution around the Sun. Its moon includes the popular Triton, its largest satellite, and the first Neptune moon to be discovered. While other satellites move in the same direction as their host planets, Triton moves in the opposite direction to Neptune. This suggests that it could be an ice dwarf that was captured by Neptune's gravity. One of the things Voyager 2 discovered is the great dark spots in Neptune. The spots are caused by fierce winds. This wind can blow up to 1,200 miles per hour or 1,931 kilometers per hour, the highest wind speed ever recorded in the solar system. At 4,600 miles in diameter, Neptune's great dark spot is almost as big as the Earth. Terrifying, isn't it? Unlike the Earth, the cause of these fierce winds is not the Sun. Scientists believe these winds might be caused by the reactions in Neptune's core and gases in its atmosphere. Neptune has a form of an internal heat source that emits more than double the energy it receives from the Sun. To put it in perspective, Neptune receives little sunlight and is more than 50% farther from the Sun than Uranus. Still, it has the same temperature as Uranus. It also has a warm atmosphere, mainly made up of hydrogen and helium. These two gases make up 98% of the planet's atmosphere, and methane gas makes up the remaining 2%. The methane gas is responsible for the blue appearance of Neptune. It absorbs red light in the atmosphere, causing the light that reflects out of Neptune to have a bluish hue. Uranus also appears blue, but Neptune's hue is more captivating. Around 10% of Neptune and Uranus is believed to be made up of carbon. Remember when we said that Neptune's icy layers have oceans under them, and that these oceans are not made up of water? Scientists have revealed that not only is there an ocean of liquid diamonds lying under Neptune's icy layers, but that it could be raining diamonds there. Makes you want to visit Neptune with a deep bucket, doesn't it? If you're thinking, if diamond is the hardest known material, how can it be liquid? You're not wrong. Diamonds might be relatively common on Earth, but it is an incredibly hard material, so it isn't easy to melt. But that's not all. Diamonds' nature and material composition make it even more difficult to analyze their melting point because diamonds do not remain diamonds when they get hot. When a diamond is exposed to extreme temperatures, it physically turns into graphite, and the graphite turns into liquid. So how was Neptune able to have an ocean of liquid diamonds and not graphite? A group of scientists tested this theory by taking exact details of the melting point of diamonds and tried to replicate what was happening on Neptune in a lab. To do this, they have to find a way around the diamond turning into graphite when it is heated. After all, they were looking to replicate liquid diamond, not liquid graphite. First, they created a condition similar to the ultra-high pressures on gas giants like Uranus and Neptune. Then they took a small, clear, natural diamond that is only 0.5 millimeter thick and not more than 1/10 of a carat by weight, and blasted it with lasers at ultra-high pressures. The team was able to liquefy the diamond at a pressure 40 million times greater than the normal pressure one might feel when standing at sea level on Earth. When this was achieved, they slowly reduced the pressure and temperature. When the pressure went as low as 11 million times the atmospheric pressure at sea level and the temperature reduced to around 50,000 degrees, the scientists noticed chunks of diamonds appearing. The pressure continuously dropped, but the temperature of the diamond stayed the same, and even more chunks of diamonds were formed. Then the scientists noticed something incredible. The chunks of diamond were floating. Tiny diamond icebergs were floating in a small pool of liquid diamonds. The melted diamond behaved like water, with the solid state floating in the liquid part. The experiment replicated the ultra-high pressure and temperature found on Neptune and provided concrete backing to scientists' belief that an ocean of liquid diamonds is beneath the icy layers of the ringed planet. But does this mean that it also rains diamonds on Neptune? Due to gravitational contraction, the temperature of Neptune's core can get up to 7,000 degrees Celsius or 12,632 degrees Fahrenheit, similar to the Sun's surface. Neptune's core emits extreme heat and pressure, which turns hydrogen gas into liquid metallic hydrogen. The methane in Neptune's atmosphere decomposes, and as a result, its hydrogen atoms dissolve, leaving only the carbon atoms. These carbon atoms then bind to one another under intense pressure and form diamonds. So yes, it could also be raining diamonds on Neptune. The interesting thing about the experiment is not just that it confirms the plausibility of an ocean of liquid diamonds, but it presents a new way of understanding planet Neptune. For one, The ocean of liquid diamonds could be responsible for the mismatch of Neptune's magnetic poles with its geographic poles. A vast ocean of liquid diamonds is capable of deflecting the magnetic field out of alignment with the planet's rotation. Scientists have always believed that it rains diamonds on Uranus and Neptune, and this experiment shows that it is possible. Nevertheless, more research needs to be carried out to know more about the composition of this planet. The Voyager 2 is the only spacecraft to have flown close to the gas giant. Even then, it was only around 2,983 kilometers or 4,800 miles close to the planet. Future spacecraft need to get closer and study the planet, but its distance, weird magnetic field, and fierce storms could pose a danger to the mission. However, it took Voyager 2 12 years and an average velocity of 42,000 miles an hour to get close to the planet, so any plans of getting to Neptune anytime soon will have to start now. Scientists have a better plan, though, and are waiting for Neptune's orbit to be closer to Earth, so that the space probe we send can benefit from gravity assist from Jupiter. As more powerful telescopes and space observatories are manufactured, it might not be long before we discover even more astonishing things about Neptune and our universe. As we come to the end of our journey exploring the wonders of Neptune, we hope you've enjoyed learning about this enigmatic and mysterious planet. From the possibility of diamond rain to the mystery of its internal heat source, Neptune is a fascinating place that continues to surprise and intrigue scientists and stargazers alike. But our journey doesn't have to end here. If you're hungry for more knowledge and curious to learn even more about other captivating planets, we invite you to continue your exploration with this next video. Scientists discovered insane planet made of diamond. In this video, you'll be taken on a thrilling adventure that dives deeper into space's fascinating features and everything in between.